This video will solve some kinematics problems without numbers, without any given values or anything like that. Um, so I'll kind of explain as we go along. So it says an object initially at rest. And so right away, I'm going to start filling in my list with quantities that do tell us. If they tell us it's initially at rest, we can still put a zero here. And it's moving to the right. We don't know the acceleration, so we can't put anything there for that. But we do know it reaches final velocity v in time t. It says derive an equation for the distance d. Okay, so we know it's going to start at zero position. That's how we normally solve these problems. And the final position, well, that's going to be the distance that it traveled. And we need an answer, we need it to say, we need an equation that says d equals, and the only letters we can have over here are v and t, and that relationship is what we need to figure out. What is the relationship between v and t and other fundamental constants? So I guess the first thing I was going to say was, we're going to look at our three kinematics equations, which you should have in the notes, and I don't have them handy, so I'm going to write them down. And essentially, what we need to do first is figure out what is A. I know it says unknown, but we can figure out A in terms of VT and constants. And the simplest equation we can try is the first one. Can we turn this equation? Can we figure out what A is in terms of V and T and constants? So let's try it. So we're going to replace V with what is known, that is V. That's the final velocity. We know it started at rest, so we'll get rid of the zero. Okay, we don't know A, but it says we do know that it takes time t to get there. Um, and if we rearrange this for A, we'll just divide by t. And so now we know what A is in terms of quantities that they allow us to use. So over here, I'm going to write V over t. It's a little v. And now we can figure out what D is in terms of those of V and T. Um, so what equation is best to determine T? I don't know, it should work with this one too, but this one's already set up. X is going to become D, so I'm going to use this one, second equation. As you are doing practice on these things, the worst that can happen is you get stuck and then you try something else. So V naught is 0 times T, the whole term is 0. And so we're left with 1/2 times A, which I can't leave it as A. I'm going to put V over T, and we'll put T squared. And we'll just simplify this. One of these T's cancels, T squared over T cancels, and we're left with V T over 2. Say that again. There we go. Oh, and you should always double check at the end. Okay. Did I make an equation for D in terms of VT and constant? So here we have VT and 2 is a constant. So I'm going to steal this because we'll probably need it for the next one. Let's go to the next one. Two rats are initially side by side at x equals 0. And whoops. So here are the two rats. I can't really put two dots, but they're at the same place. And they both start moving to the right. Rat A moves with acceleration A, while rat B moves with acceleration 3a. So let's go ahead and transfer that list. And we're going to need 2 because we have 2 rats. And if we're going to make these two lists, We should label them. This is rat A, and this is rat B. Okay, all we know is they both start at 0 position. They both start moving, which implies that they started from rest, both of them. And rat A moves with acceleration A, rat B moves with acceleration 3A. Okay. Derive an equation for the distance d. Ah, yes, the distance d between the rats at time t. So the rat gets there, both the rats get to their final positions at time t, and we want to know what is the distance between the rats. Okay, so both rats start here. Yeah, so just say x naught equals 0. We want to know the distance d between the rats at time t. So which rat will get further? And it's the one with the acceleration, right? So rat B will be somewhere over here. And for now, I'm just going to put B. And A is going to be lagging behind. It has less acceleration. So you can imagine that they're going to be some distance apart sometime t later. And we want to know what is that distance between them, d. And so we can just, as an aside, just write this equation that the distance between them will be the final position of B and minus the final position of A, right? And I'll make some notation. I'll say final position of B minus the final position of A. And so over here, I want to say that's what we're stating, that final position of rat B and A, I chose this notation to use. Okay, and let's make some expressions for, this is our goal. We're going to make some expressions for XA and XB, and we're just going to subtract those expressions. So let's do that. So can we take this list of numbers, or not numbers, it's numberless. Can we take this list of quantities that we know and make an equation for XA? And we do. We know that the second equation is a convenient one to use. And right now I'm just writing down, and we're going to need this for rat B as well. I'm just writing down the original equation without having manipulated anything. So it always start that way. So I'm going to take this equation, and what I'm trying to solve for is, let's zoom in here, is XA, right? So we're replacing X with XA. X naught is 0. V naught times T, well, V naught is 0 times T is 0. And so we're left with 1/2. The acceleration of rat A is A, and the time it took rat A to get there is T. Well, we're going to have to square it. And let's do the same thing with rat B. Replace X with X sub B. X naught is 0. This term is 0. Now the acceleration of rat B is 3 times the acceleration of A, so I'll put that in here. But it'll arrive there at the same time, T. And I think I'm just going to say 3/2 AT squared. I think I'll write it like that. Bring the 3 up here, and you'll see why in a moment. So now I have an expression for XA and XB, and so let's substitute those here. This is 3/2 AT squared minus 1/2 AT squared, and so they both have AT squared. 3/2 minus 1/2 is 2/2 AT squared, which is just AT squared. Double check. Did we answer in terms of AT and constants? Well, AT and the T squared is going to be fine. Cool. So this relationship is, has meaning to it, of course. Whatever the acceleration of rad A is, rad B will have 3 times the acceleration, but the distance between them will be a function of, um, that initial acceleration of rad A and the time, is a function of time. So you can plug in any time here and you'll get the distance between them. And over here, this one also had meaning. So um, we can know what the distance traveled by this object is if we know what its final speed was and how much time it took to get there, and plug in those numbers and figure out what that distance is. It's just a general way of solving an equation without knowing specifics. Okay, that's it.